Hi, this is Chaitanya Malladi from ENH iSecure Private Limited. As part of this presentation, we will be understanding what privileged account security is and how CyberArk approaches it. We will begin by understanding privileged account security and how CyberArk implements it. We will take a look at the various components of CyberArk and how they fit into the architecture. Then we will understand a few utilities that come with CyberArk. Finally, we will take a look at how high availability and disaster recovery can be configured. In any enterprise, we would be coming across a huge number of accounts. Out of these, a few accounts have higher authorizations or higher accesses. Those accounts are considered as privileged accounts. A few examples of these would be a root account on a Linux machine or an administrator account on a Windows machine, or the DBA accounts on databases. These accounts have higher control over the system they are on, and if they are compromised, the vulnerability or the risk that comes with them is also much higher than the regular accounts. For this reason, we need to ensure that the privileged accounts are better safeguarded. This is where products like CyberArk come in and help us manage the privileged accounts better. Let us now take a look at the various components of CyberArk and understand briefly what functionality they perform. The vault or the password vault is the most important component of the CyberArk implementation. All the credential files and the configuration files are stored within the vault in a secure manner. The Central Password Manager or CPM is a component that is responsible for managing the password files. It is also responsible for maintaining various policies on different platforms. The Password Vault Web Access is a component that provides an interface for the user to interact with the CPM or the vault. This is done via a web application. These three components together form the core PaaS solution offered by CyberArk. In addition to these, there are few other components that perform specific functionality. The Privileged Session Manager or PSM is a component that is responsible for monitoring live sessions. It also enables session isolation for various sessions that are simultaneously created. The Privileged Threat Analytics component is responsible for monitoring the system and identifying potential threats that exist within the system. The Privileged Session Manager SSH Proxy is a component that allows users to connect to Unix machines via SSH using native workflows. At the same time, it also allows monitoring of these sessions. The Application Identity Manager or AIM is a component that allows applications to use privileged accounts to perform their tasks. The configuration of which applications is allowed to use which privileged accounts is also performed. The On-Demand Privilege Manager or OPM is a component that provides elevated access for the users on request. This ensures the least privilege policy is used on the target. The SSH Key Manager is a component that allows management of SSH keys to privileged accounts from CyberArk. We will now move ahead and look at each of the components individually. The password vault is the heart of the CyberArk implementation. It holds all the relevant files to the CyberArk system in a secured manner. The vault consists of various safes on which authorizations can be provided for users or other components. Each of the safes can contain a combination of passwords, configuration files, or any other files. The security is provided on this system by encryption on each of these layers. In addition to the hierarchical layers of encryption, the security of the vault is ensured by making sure it is installed on a dedicated server that is then hardened. The process of hardening removes all unnecessary services and configures the firewalls so that only Vault can communicate in and out of the server. The Central Password Manager is a component that handles all the tasks that are related to password management. Platforms are nothing but the definitions of how the CyberArk system can connect and communicate with the target system. The CPM is responsible for maintaining these platforms. It also handles password policies where, based on the platform, the complexities of the passwords and how often they're verified and changed can be defined through the Central Password Manager. And of course, it is also responsible for maintaining and managing the passwords. The actions of verification, changes, and reconciliation, if required, is performed by Central Password Manager. The Central Password Manager itself does not hold or store the credential and configuration file. All the storage is securely done in the vault, and any of the password files are retrieved and stored from the vault as and when necessary. Even the policies and the platform details are stored on the vault and are used from the vault when required. The Password Vault Web Access is a web application component that provides an interface between the user and the CyberArk system. In a CyberArk implementation, this component is the only component a user will interact with on a day-to-day basis. For a user, the accounts are available through the web application. As an admin, one can also configure or make changes to the CPM through the PBWA application. The Privilege Session Manager is a component that creates sessions to target systems and provides these sessions to the users instead of sharing the password with them. This enables session isolation. This means each of the users is provided with an individual session, and each of the sessions can be isolated even if multiple users were using the same account at the same time. PSM also enables monitoring of these sessions, either the ones that have occurred in the past or the ones that are happening at that point of time. The Privilege Threat Analytics or PTA is a component that provides a way of monitoring all the accounts in the system. This monitoring is done in real time to identify any threats or anomalies in the system. Once these threats are identified, they are acted upon either automatically or by providing an alert to the corresponding authority. For instance, if PTA identifies that an unrecognized IP address has logged in to one of the systems, it immediately discards the session and changes the password of that account. PTA can also be integrated with other SIEM solutions to provide more functionality. The Application Identity Manager or AIM is a component that enables control over how applications use privileged accounts. It replaces the hard-coded passwords stored within the application source codes or in configuration files, and instead it provides the password to the applications on request. There is also control over which applications is allowed to use which of the accounts, and the usage is also monitored by Application Identity Manager. Privileged Session Manager SSH Proxy or PSMP is a component that enables users to connect to Unix-based targets over SSH. These SSH sessions are initiated using PSMP component and not connecting directly to the target systems. This ensures that the credentials are not shared with the user. It also ensures that the sessions can be isolated and also be monitored to record the activities performed by the user. PSMP can also be used to restrict unauthorized commands during a SSH session. SSH keys are a way of authenticating to SSH-based target machines as an alternative to password-based authentication. The SSH key to a privileged account comes with the same risks and challenges in terms of security as the privileged account password. So, in addition to managing the privileged account's password, we also need to manage the SSH key. This is where the component of SSH Key Manager comes into play. It provides a secure storage for the keys and ensures that they are rotated at regular intervals, just like the passwords are changed. It also helps to have control over who has access to the keys. The On-Demand Privileges Manager, or OPM, is a component that enables control over superuser commands issued using a root account or a privileged account. This is done by not allowing a user to log in as the root account. Instead, the user logs in with their own account and issues elevated commands using OPM. This ensures that the commands that are allowed can be controlled, and hence we can enforce the least privilege policy. Next, we will understand the architecture at the core of the CyberArk PaaS solution. Let us start by considering the target systems. These might be operating systems or domain controllers, databases, application servers, network devices, or any other target system which consists of privileged accounts that are to be managed. On CyberArk, the vault is where the credentials for all of the privileged accounts are securely stored. The component of Central Password Manager communicates with the vault and maintains the platform definitions, the password policies, and also performs password management tasks. In case a password change is required, it is CPM that initiates the change on the target machine and also updates it in the vault once the change is successful. The web application of Password Vault Web Access acts as an interface between the vault and the user. When the user wants to initiate a privilege session with one of the targets, it is from PVWA that the user can retrieve the credentials and then initiate a required session. The Privilege Session Manager facilitates the users to work on privileged sessions without being aware of the credentials of the corresponding account. Such a session can be requested using the web application of PVWA. When a request is made, PSM initiates a connection to the target using the requested account. Once it is connected, this is provided to the user as a session via RDP. Next, let us take a look at the utilities that can be used to interact with the CyberArk components. PrivateArk Client is an application that provides the user with direct interaction to the vault. From the PrivateArk Client, a user can see the safes present in the vault and available to them, and also the contents of the safes. The PrivateArk Client can also be used to perform vault level configurations. For example, the users and groups can be modified. The safe level permissions or the network areas can also be customized using the PrivateArk Client. The PrivateArk Command Line Interface, or PSCLI, allows the user to communicate with the vault via a command line. All the functionality of the PrivateArk Client is also available in PSCLI through command line. This also enables the possibility of having scripts to automate tasks on the vault. The Remote Control Client allows the user to control the working of the vault server from a remote machine. The user might issue commands to retrieve the status of the vault or the server information, or to start up the vault from a remote machine. Replicate is a command line utility that helps the user to take backups of the vault. This backup can be taken as an incremental backup or a full backup as per the requirement. The password upload utility can be used to onboard a large number of accounts automatically. When a CSV with the account information is provided, the password upload utility processes the file to find the account information and creates the necessary files on the vault. Let us now understand how the components communicate. In the CyberArk architecture, none of the components communicate among one another. All the component communication is done via the vault, and any third-party application or the user needs to interact with one of the components to communicate with the vault. This increases the security of the vault and also the isolation of each of the components. Lastly, let us understand how high availability and disaster recovery can be configured. In a large implementation, it is possible that a single vault cannot handle the number of requests that are coming in. In such a scenario, one can go for high availability clustering, where multiple vaults are working together to serve the requests. Disaster recovery needs to be configured on critical environments where unavailability is not permissible even for a short time. In case of CyberArk, disaster recovery can be configured on the vaults by having them in an active-passive mode. The active vault continues to serve requests while the passive vault synchronizes with the updated information at regular intervals. In case of a disaster where the active vault goes down, the passive vault is brought up and can continue to serve the requests. That concludes this presentation on CyberArk architecture. Please follow us on our social media for more technical content. Thank you.